they so desire. Okay, so today we're going to talk a lot about things in the coordinate plane. There's a lot of geometry that can actually be done in this coordinate grid system. So you see a graph up, just a reminder of the coordinate grid system in general. The horizontal line, so going from left to right, that's the x-axis. And the vertical line going up and down, that's the y-axis. So when you're on the coordinate plane, each crosshair where they meet can be a coordinate listed. I'm going to actually change that point. I'm going to put it over here. And that coordinate always goes your x value first and your y value second. So if we need to actually give it a coordinate name, a point, we count from the center. The center is called the origin. And since x value is first, you have to travel on the x-axis first. So going right until you're directly under the point, how many spaces did we go to get under that dot?
2.
2. So the x value is a 2, and then how many spaces do we go to get up to the dot?
1.
1. So this coordinate would be 2, 1. So that's just a general review of how the coordinate grid system works. So now let's actually address the problem. The problem states, where should point D be located in order to make quadrilateral ABCD a parallelogram? So when they use this notation, quadrilateral ABCD, that just means...
Quad means 4.
Yep.
You know that.
Yep, so if you connect the dots, it'll be a shape with 4 sides. That's exactly what quad means. Do you know what a parallelogram is?
When the sides are parallel towards each other, like both sides are the same.
Yep, so when the sides are parallel to each other. So rectangles are one type of parallelogram, but the ones we think of the most often is if you took that rectangle and tilted it, the sides are still parallel, but now it looks like you kind of tilted it over, and that's a parallelogram.
Yeah, and that's what we need to draw here.
Yep, that is exactly what we need to draw here. So this is one of the problems where using the answer choices can really help. Answer choice A states 0, 0. If the fourth point were here at 0, 0, and then we connected the lines, does that look like a parallelogram?
It does, yeah.
Kind of does.
But one line looks a little, it doesn't look like it's even on that side.
Yeah. What I can do, because drawing them by hand is probably what's throwing it off. Oops, that was not what I wanted to do. Let me try this again. I'll just go over with a new color. I'm going to use purple, and I'll use the actual line tool so it's exactly straight. It's hard to draw a straight line with a mouse.
Yeah.
Okay, so now those lines are straight. And if we connected to the dot in the center, use blue.
Still, you're going to have the bottom one short, though.
Yeah, the bottom one seems a little short. So A, kind of maybe, but let's check the others and make sure there's not a better option. So then we'll try answer choice B. Answer choice B is -1, 0. So this is why it's so important to know, do you go X or Y first? Because when it's -1, 0, you have to know I go on the X axis first. A lot of people get them confused and would go down, but -1, 0 is left first. So if we connected to this new dot, is that a parallelogram?
Yeah, that looks like one.
Okay. But also, so again, let's make sure there's no better options. We have negative 1, 1.
That's going to throw it off.
1, 1. That's up here. Because negative 1 is left 1, and then positive 1 takes it up.
Actually, that looks like that would be it.
So this one actually looks the best so far. So we think it's probably C. Let's double check D just to make sure we're not missing anything. D says 0, 1. So again, now that it's 0, because X is 0, we don't go on the X-axis at all. The 1 is on the Y-axis. So
that's going to be too short.
Yep, too short for this one.
So their best answer would be C.
Yep. So even though some of them kind of look like it, it's best to check all of these answer choices to make sure we find the one that looks the most like a parallelogram.
Do they give you time on the test, though, to go through all of them?
Yes. I think you have like 2.5 hours total. Like you have a very long testing window. You have plenty of time.
But I got to do 2 in one day, though.
I think you can't do 2 at the same time, though. Like if you have a morning testing time, you'd have to do the second one at an afternoon testing time. So you should still have plenty of time to complete the entire math test.
You got to put your homeroom number on that.
This junior high is offering a candy bar sale.
Okay. So still in the coordinate plane. Like I said, today is all about the coordinate plane. Point P is located at negative 4, 4, so they actually give you the coordinate already. And Q is located at 2, 2. What is the distance between point P and Q? So distance requires a specific formula, and thankfully it is not one you have to have memorized. You still have, even though it's going to be a computer test now, you still have access to this reference sheet. You can pull it up at any time during the test. And one of the formulas on it is the distance formula.
Oh, wow.
Yeah, it is kind of a complicated formula. So, with this distance formula, how do we plug stuff in? There's a lot going on here. Okay. So each of these actually means something. X with the little 2 below, this is not, like X squared when you have a 2 above, that means an actual math process. When the 2 is below, it's just because it's the X coordinate, but it's from the second point.
Okay, so would we have to do, like, for the X2, do the negative 4 2 times?
Not 2 times. It's just saying this is the second point. You're working with 2 points, so we can call this the first point and this the second point. And it actually doesn't matter if you wanted to call the negative 4, 4 the first point and the 2, 2 second point. That doesn't matter. You just have to pick. Once you've picked, we say, okay, what's the X coordinate of the second point? So what number is the X number of the second point?
It's negative 4.
Negative 4. So we only use it one time because it's not saying squared or add 2 times. It's literally just saying this is the number you get from the second point.
So what's the 2 for, though?
That's to say the second point. It's because you're working with 2 different ones. Since this is an X value and this is an X value, we can't just say X. We'd be like, well, which one? We have 2 of them. So the 2 is just to say this is the second point. So then what's X1? What's the X value of the first point?
Okay. The first point is, it'd be 2.
It would be 2. X value of the first point is that 2. So -4 minus, and the minus is just because the minus sign of the formula 2. Now we do the same thing but with the y values. So we want the y value of the second point.
It's 4.
And y value of the first point.
It's a 2.
Good. So now we need our calculator. Some of it you could do in your head, some of it you won't be able to. So in our calculator, we still have to follow order of operations. We would have to do what's inside the parentheses here first, the -4 minus 2. And I just used the keyboard. You could also use the buttons down here. So like the next one, on the next line, I would do the 4 minus 2. Those were the y values. So we got -6 for the first answer and 2 for the second answer. So then before we can add, we've got to do the exponents. So when we do the exponents, you can do it 2 ways. You can type it in with the parentheses, or you can remember, well, squared means do -6 multiplied by -6. So if you want to, sorry, say that again.
And that's 36.
It's 36. So you could type it in, or if you already know, we just know that, yeah, that's 36. And then we have to do 2 squared. That means do 2 times 2.
4.
4. And then we can add, what do we get from the 36?
40.
40. So square root of 40, that's something we can't do in our head. A lot of these steps you could just do in your head. Square root of 40, we must use the calculator. And the square root button is the check mark. It looks like the beginning part of the square root. So what do you notice though? What kind of answer do we get?
A crazy one.
Yep, crazy long answer, 6.324. So they did not write any of the answers like that crazy answer. So what we have to do is we have to actually take each answer choice and plug them in and see if we get the same crazy answer. So like answer choice A is square root 10. Go to the calculator, new line, because we want to keep seeing that crazy answer so we can compare. We try square root 10 and then we say, is that the same crazy answer?
No.
Nope, not the same. It has to be exactly the same crazy answer. So answer choice A is out, not our crazy answer. So then we try answer choice B, 2 square root 10. Now do we get the same crazy answer?
Yes.
Yes. So now that it's matched, it's exactly the same. We know answer choice B is correct.
Wonder why they put it like that though.
So there is a reason they do it. It's because since you get a crazy answer, you have to round. I have to cut off that decimal, and it's not as precise. If I ever had to use this again, then we'd want the problem written like this, is 2 square root 10. So there's actually a way to get that from this, but it's a longer process, and so to me it's easier to just use the calculator. Do you want me to show, though, how you could get from square root of 40 to 2 square root 10 written exactly like that?
Is it a lot to do that, or?
It's not super bad, just I try not to include too much extra stuff that's new, where using a calculator is something you're familiar with, I thought that's a quicker, easier route to go.
We'll just stay with the calculator.
Okay. Okay. Okay, so next one. We're still in the coordinate plane. This time we have a new shape, triangle, but it asks for what is the midpoint of side AC. So when it says side AC, that means you start at A, you go to C. That is the line that goes from A to C. And it wants the midpoint. So midpoint is not included on your formulas. They expect you to have midpoint memorized. So when you find the midpoint, you're basically taking the average. But we have to do it twice because every coordinate has 2 points. So let's name the points first of all. If we were going to get to A, what would we label this coordinate? If we start from the center, how far over do we have to go? And then how far up?
2 and 2.
2 and 2. Keep in mind the
2 and then 2.
Yep. When you go left, even though it was only 2 spaces, we need to say -2 to say, well, we went to the left 2 spaces. How about C?
C is over 2.
Over 2 and no up. So when there's no up or down,
that's 0.
Mm-hmm. Yep. So again, we have a first point and a second point. We have 2 different points we're working with. So when we say to find the average, we have to find the average of the x values only, and then find the average of the y values. We have to do the 2 separately.
What would happen if you did them together? Like did the -2 and 2 and then add the 2 and 0?
You could. So if you wanted to kind of keep it all together, you could say almost just like add the whole 2 points together. But you still have to do the 2 additions separate. Though only those 2 add together, only those 2 add together. Mm-hmm. But we can do that. So what do we get when we add those 2 together?
It'd be -4, wouldn't it?
We have a -2 plus 2.
So 4.
It's actually going to be 0. It's kind of a tricky one because we want 2 and 2 to be 4 no matter what. But if you think about it on the number line, if you start at -2 and then add 2, that means you're going right 2 spaces. That's
okay.
Takes you to 0.
All right. Okay.
Yep. So that is 0. We had a new student join, so I'm going to pause really quick and make sure it doesn't look like his sound is on. Oh, now his sound is on. Ray, can you hear me? Type a message too.
I believe the mic is muted.
Yeah, he has his mic muted, but he might still be able to hear me. So if you can hear me, you could either unmute your mic to talk back, or you could send a chat message. I just sent a chat message. Usually you have to hit like 3 dots to see the chat messages. I'm going to keep going until I either hear from you or see a message. Let me know if there are any issues and you can't hear me. So right now we are finding a midpoint. Okay, good, he can hear. So while we're going through, if you have any questions, like I said, you can unmute yourself if you want, or you can ask questions through the chat. I try and look at both. So we're finding the midpoint on the coordinate plane, and it was specifically from point A to C. So we figured out, well, the first point, point A, is at the coordinate -2, 2, and the second point, C, is at 2, 0. And to find the midpoint, the middle of them, we have to take the average. So right now we're kind of doing it together. We said we're going to add all the x values together and all the y values. We added the x to get 0, and now what do we get when we add the y values together?
That's 2.
2. But we are not finished. When you take an average, after you add stuff together, you still have to divide. What are we going to divide by?
By 2, maybe?
Yes, by 2, because we added 2 things together. When you average, you say, well, how many things did I add together? That's what I divide by. So now we have to divide by 2. So what do we get when we do 0 divided by 2?
Wouldn't it be 0?
Yep, still 0. And what do we get when we do 2 divided by 2?
1.
Good. So 0, comma 1 is our midpoint. It's the middle. And you can even kind of visually see it. Sometimes it's easier to even just look at it and say, well, what looks like the middle of the line? Kind of looks like it's right there. Only one of the options is in the middle. Okay, so still doing coordinate plane. All these questions today are about the coordinate plane in different ways. This time it says, what is the slope of side DE? So same idea with the sides is we just look at the points from D to E. Is this side up here? Slope is another formula that's not on the reference sheet, unfortunately. They give you distance, but they don't give you midpoint, they don't give you slope. Those ones you have to have memorized. And midpoint, you can just get the general concept, find the average. Slope is a little harder, so we kind of have to just have the whole formula memorized. But it does seem kind of crazy with all the amount of information in it, kind of like distance. There's a lot going on here. We have this sub number again, y with a 2 underneath, y with a 1 underneath. But it still means the same thing. It's still talking about what's your first point, what's your second point. So we need coordinates. What is our coordinate at E?
It's -3 and... Oh, wait a minute, did I do that wrong? -3 and 4?
Good. -3 and 4, and you did it correct. You go left first, or if you are going in the other direction, you'd have to go right first. It's just left or right first, and then up or down.
I was confused for a minute, though.
Yep. So what about coordinate D? What do we get for coordinate D?
Okay, that is 1.
Mm-hmm. This time we did go right first.
Is that a 5? Yeah, 5.
Yep, that is a 5. Yeah, sorry, the numbers are kind of small. So again, we're working with 2 points, which means we need to say one of these is first, one of these is second. It doesn't matter as long as you pick it. Like, if you have scratch paper, you may even want to write down, this is the first point, this is the second point. So once you've picked those, now we have enough information to plug stuff in. This y with the 2 underneath is saying y value from the second point. So what's the y value of the second point?
That would be 5, because your x value is first.
Yep, correct. That is 5 because the 1 is an x value because it came first. Minus, the formula says you have to subtract, and then y1. What's the y value of the first point?
4.
Good. Now we go through again. this time with our x's. What's our x value of our second point?
That is 1.
Minus from the formula, and then x value of the first point?
-3.
Good. So 5 minus 4, that's not so bad. What do we get from 5 minus 4?
That's 1.
1. But then it gets a little trickier when we have 1 minus -3. That's 1 minus -3. So if you're ever unsure, you're like, I don't know, that's kind of a weird setup, try the calculator. So again, I'm pretty confident that it's this Desmos calculator. I've asked Amy to double check just to make sure, but since it's online, I think now you use this online calculator. And we would do 1 minus -3, and it pops up our answer for us.
Just 4.
4. So when you have that minus minus, technically it's 1 plus 3. No.
Yeah, because you can't subtract 1 from 3.
Yep. I'm going to have to refresh my page really quick. It's not letting me write anything. Sometimes when I switch tabs, it doesn't like that. So yeah, the 1 minus -3, you can't really do the two symbols at once. You either have to change it to the plus, make it 1 plus 3, or you just plug it into a calculator. So now we have our slope. Sometimes you might have a fraction you have to reduce. Let's say instead of 1/4, well, let's pick our answer first. So what's our answer for this particular question before I go off on a tangent?
It'd be C, 1/4.
1/4. Now, sometimes you might go through that whole process, you find the slope, but when you find the slope, let's say you get 2/8, and you're like, my answer doesn't match anything right now. That doesn't necessarily mean you're wrong. You might still have done everything correctly. With fractions, you always want to check, can it reduce?
That'd be 1/4 too.
And it does reduce. I picked it so it would reduce to the answer we already had on the page. It reduces to 1/4 because you can divide the 2 by 2 to get a 1 and the 8 by a 2 to get the 4. It just always has to be divided by the same thing, and it reduces the fraction. But it's always something to watch out for. Okay, so those were all kind of formulas in the coordinate plane you might need to use. Now we're going to move on to something called transformations in the coordinate plane. It's more about taking a shape and moving it around. So they'll usually give you an original shape. This is triangle PQR. The letters are kind of small. It goes P, then Q over here, then R. And it says, which graph shows the image? We're going to talk about that word in a second. Image of PQR translated 6 units left and 4 units down. So image just means the picture you get after you do some sort of movement. This is your original. The original is actually called a pre-image. I don't know who chose these words because I feel like they're kind of confusing. But pre-image means I haven't done anything to it yet. Image is now I've moved it. And you probably can't see, these letters are so very small. This now says P with an apostrophe. You might hear me say P prime or Q prime. The apostrophes in math are actually the word prime. And that means I've done something. I've moved a shape. I've moved that pre-image and got a new shape, a new image. So we just want to specifically move it in the direction they tell us. When it says translated, you're basically just sliding it. A translation means slide it around. So if we're going 6 units left and 4 units down, you can think of it as the whole shape and try and move the whole shape that amount. Let me show you with a line. if I went from P to R and had this line, I could think of, no, come on. The whiteboard's not doing what I want it to really quick. There we go. You could think about moving this entire line and saying, well, that's 1, 2, 3, 4, 5, 6. And then you can say, well, the next is 4 units down. 1, 2, 3, 4. And that's where my new left line should be. So what's the only shape where the left line matches up to where we got after we counted?
It would be, let's see, not that one. I'm going to say D, maybe.
D. And you're right. That is the correct answer choice. But it's hard taking the entire shape at once. We only even got to move one piece and not the entire shape. So instead of doing that, usually what I do is take each corner and move each corner to see where we'll end up. So like if we started at corner R, we go left 6 spaces, 4 down. And you're basically literally just counting on this. This slide is a lot about counting. When you count, the original spot has not been moved. This is not 1. 1 doesn't happen until you've actually gone a space over. So 1, 2, 3, 4, 5, 6. And then we also have to move 4 spaces down. 3, 4. We get where that new point is. And then you have to do the same thing, but with P and Q. I'll just pick a different color. So if we go P and we go 6 spaces left and 4 spaces down, now we get a new point for P. And if you do Q, we do 6 spaces left again. I went a little too far. Let me try that again. And 4 spaces down. And now you can get the entire new shape so that it compares a little easier. So you kind of have to go corner to corner. When you're doing it on a test, you probably won't have as much drawing on there. It gets confusing with all the colors, but I was trying to show you where my counting was actually happening. You'll just get your final shape and it'll be easier to match up. But D was the correct final shape. So this one is a pentagon, is shown on the graph below. Which graph shows the pentagon reflected across the y-axis? So
Well, it could be on the other side, or it could be on the bottom.
Yep, it's either on the other side or it could be on the bottom, and that's where the y-axis comes into play. So reflection is a flip, and the y-axis is the important part. That means we're flipping across this line. We're going over here. So which one gets actually flipped across the y-axis?
I want to say A.
Yep, good. If it said to flip across the x-axis, that answer is also there. Which one is flipped across the x-axis?
B.
That one is B. Instead of going to the left, this time we're going down. That is B. I'd also like to point out it used the word pentagon. Normally when we think of a pentagon, we think of this shape. But really, what makes something a pentagon is it has 5 sides. And even though this shape looks almost like a boot, it's still made up of 5 straight lines, so it's still considered a pentagon. So we had translations, we have reflections. We also have, so another version of a pentagon. Again, this is 5 sides. And 1, 2, 3, 4. Nope, I just have the instructions wrong. I typed it wrong. This is a quadrilateral. Sorry about that. There are only 4 sides, so it is not a pentagon. I just copied it wrong. 2, 3, 4, yeah. Which graph shows the image of the quadrilateral rotated 90 degrees? Sorry, more specifically, rotated 90 degrees counterclockwise about the origin. So clockwise versus counterclockwise, if you imagine an old school clock, I think I'm labeling this totally wrong, 12, and it's been such a long time since I've needed to draw a clock.
Yeah, 12, 1, 2, 3, 4, 5, 6. I still have a clock like that.
Gone digital. It's hard to remember sometimes. So clockwise is if you're going in the correct direction around the clock. You're counting 1, 2, 3, 4, 5. Counterclockwise is when you're going against the numbers. If we started at 12 and went 11, 10, you're counting backwards. So we want to go counterclockwise. We're going, and I almost always draw it out. I always forget, and I always have to be like, okay, which one's clockwise, which one's counter? Got to draw it out. For me, that just makes my brain a little happier. And then it said about the origin. We're going to take the shape. It's almost like it's attached to a line here. And we're going to rotate the whole shape using that line like it's a lever. So which one looks like it's been rotated 90 degrees in that direction?
B.
Okay, so B. Okay, B looks like the shape has been rotated 90 degrees, but the center of rotation is the middle of the shape. Like they took that shape and just turned the shape right where it's at. And that's
okay, so that's A then.
Okay. A has been rotated 90, but it's been rotated 90 clockwise. This is why they used the word counterclockwise versus, you've got to know where you're rotating and what direction. This one, you're going in a clockwise direction.
Okay, Ray says D.
Yes. Oh, well, again, it's super important to know not just that it's been rotated. That one's closest. The correct answer is C. I had C and D flipped in my head when I said yes originally. I thought I got the two mixed up. The problem with D is when you do the counterclockwise, even though D is close, it's in the right direction, you got the counter, it's not quite 90 degrees. If we kept that lever on it.
Oh, okay, so it was just flipped up on the other side.
Yeah, it just kind of flipped it up. It actually rotated around this point. So it didn't get rotated around the origin. The rotations are the hardest of all of these. They're the ones that get messed up the most because they're so difficult. You can rotate in so many different ways, as you're seeing. All of these are rotations. Just some of them are rotated around the wrong point. If we rotate it around the origin, you still got to have that space over to it. Does that make sense for the rotation? These, like I said, these ones are.
Yeah, just flipped it up off its side, it looks like.
Yeah. Well, it didn't just flip it because D also just flipped it up off its side. It flipped it and left that space from the center to that corner.
Yeah.
So that's that key word of about the origin. That means you still have that space from the center of the graph to the corner of the shape. You can see the rotation weird. Going on. Yeah, rotations are weird. I'm going to erase some of this so that there's not so much drawing. Let's stick with this. And instead of 90 degrees, let's go 180 degrees about the origin. So I'm going to have to maybe overlap. I'm going to have to draw out some answer choices.
Mm-hmm.
The original. These are not going to be the best pictures. I'm having to rotate in my head as we go. Okay, so the blue ones are the new answer choices. Let me get one more. This way. Okay, so from our new blue answer choices, which one was rotated 180 degrees, still counterclockwise, 183 counterclock, 180 degrees counterclockwise about the origin? There's really three things we have to think about. What direction, where's the rotation happening, and 180 degrees, what does that mean? So we knew 90 is a right angle. 180 is a half circle. So which answer choice looks like it's been rotated 180 degrees around the origin? You still have that space to the center.
It only looks like A does.
So A is 180 degrees, but it's not about the origin. Again, that keyword origin. Origin is the center of the graph. A doesn't give that space to the center where it's still going out from the center to a new. You can't have the space like be now inside. It's still got to connect to that outside point when you rotate. So A was 180, but it didn't fit the requirement of 180 about the origin. So it's out of the running. Okay, so Ray says B, and Ray, you are correct. That one's 180 still. See that they're still in the same direction. It's almost like they got flipped upside down. But you still have that space from the center to that corner. So let me think of a different way to describe it. If you yourself were rotating, if you were spinning in a circle, if you stay in the same spot spinning, then your center of rotation is you. It's in the center of you. But let's say you're spinning around a pole you're holding. If you're spinning around a pole, your arm is actually connected to that pole, and your body is moving around the pole in a circle. So that's the difference. This first one, A, is more like you're just spinning in place. B is more like you're spinning around a pole. You've got to have that connection to the pole, and you're going around that pole. Kind of hard to describe. Like I said, rotations are probably the hardest. Translations are pretty nice.
Coordinates ain't bad.
Yep. Reflections aren't as bad, but rotations are the worst out of all of them. Okay, so last of these types of questions, and it's still a coordinate plane question, but this time they didn't give a coordinate plane. So the question says, the vertices of parallelogram. We talked earlier that a parallelogram is like a flattened rectangle. And if they say parallelogram A, B, C, D, those are all the pointy parts. They could be in a different order though, depending on now what actual coordinates. They give us actual coordinates. So A is 1, 0, B is 3, 0. They give us places they will go on the coordinate plane. If the parallelogram is translated, the translation was our slide, translated 3 units to the left and then rotated 180 degrees, so that's our turn. Rotated 180 clockwise. This time we're going this direction, but still about the origin. What are the coordinates of the image of point A? So a lot going on here, and it's best to break it down. First thing is we need a picture. We don't know what this looks like at all. So you're going to have to, I'm sure you've got to have like scratch paper, something you can write on. You're gonna have to actually draw out a coordinate plane if you were to get a question like this. They don't always include every type of question that I show you on every test, because there's only a limited number of questions, but I try and cover every possible one you might see. So it does say, what are the coordinates of the image of point A? So even though it gives us an A, B, C, D, we really only care about A, and that'll help us simplify it. A is 1, 0. Is that going to be here on the x-axis or here on the y-axis? Which one is the 1 first?
That's going to be on the x-axis.
Yep. That's a hard word to say. X-axis.
I wasn't trying to cuss, I swear.
Yeah, I understand. There's a lot of hard words. It's really easy to mess them up and say things you didn't mean to. So, A is on the x-axis. The value that was an actual number is the x value. So then let's, again, we're taking it piece by piece. It says to translate it, to slide it 3 units to the left. So we want to count. Go ahead. Where are we going to end up?
1, 2, 3. The third line to the left. Right there.
Okay. When you go across the y-axis, that actually counts. They don't draw in a separate tick mark because it's all black. That counts as a movement though. We don't go 1, 2, 3. We actually count the y-axis as a space. That's a common thing that we haven't seen yet.
Yeah.
So it's actually 2 spaces left and not the third tick mark. Okay, so we just had Farah join. Thanks for coming, Farah. We're currently working on a problem where we have a couple of things to do. They gave us a shape that we want to move around, and specifically it said just point A, so even though it gave us a lot of points, I only drew in point A. And the first part of the movement was to slide it 3 units to the left. So we moved and counted 3 spaces left, and this is where our new point A is at. This is where we use that notation, the apostrophe. A prime means we did something, it's been moved. So now we're here. This actual original point doesn't matter anymore. If you don't like it on 2 coordinate or on 1 coordinate plane, if you're like, I don't want to see all this on 1 spot, you could actually draw a whole new coordinate plane and say, now I am here. This is our new spot. We've taken care of this first part. We don't need to worry about it anymore. So now we need to rotate 180 degrees clockwise about the origin. We need that lever again. When we do the rotation, let's see, clockwise means we'll be heading this way. that lever still needs to be that same distance from the origin. So we said 180 degrees is halfway around. If we go halfway around in a half circle, where is our lever going to make that point end up?
Back where it was at, well, one after where it was at before.
Good. Almost where it was at, but just a tiny bit different. That lever was 2 spaces long, and it still needs to be 2 spaces from the origin. So now we're here. When you do 2 movements, then we use 2 apostrophes to say, well, now I did something else to it. Second time I made a movement. And now we just need to pick the correct coordinate. What coordinate matches where our point ended up at?
Yeah, 0, well, there ain't no 0, 2. It'd be 2, 0, because your x, well,
Okay, so the question is this coordinate 0, 2, or is it 2, 0? So Ray thinks it's answer choice C, which is 2, 0. Farah, if you want to chime in, you can unmute yourself and talk, or if you want to give answers over the chat, you can say a chat message, or if you just want to listen, that's fine too. So, April, are you convinced? Do you agree with Ray that it's the 2, 0, or do you think it still might be the 0, 2? We got another answer. Farah also agrees with Ray. She thinks it's C. So why would it be? We have 2 people saying.
It wouldn't be 0, 2, because there's no 0, 2.
Yep.
It would have to be 2, 0.
Always think about it being on the x-axis or the y-axis. Since this point is on the x-axis, the 2 has to go in the x spot. 0, 2 would be a point on the y-axis. This would be 0, 2 because the coordinate is
Y.
Yep. Good. So those were all the questions I had prepared. We still have about 9 more minutes. So I'm going to go to the site where you can find some practice problems. So the only practice problems they have released are on this Math OGT site. If you haven't seen it before, it's a good place to go to get some practice problems. And I'm going to just pick a random problem, see if there's one related, or maybe just pick one to do. Or if you see one as I'm scrolling through that you think looks interesting. Nope. Here's one that's kind of related. So let's take a look at this one. Trapezoid RSTU is shown on the grid. So trapezoid is a specific type of quadrilateral. These 2 sides are parallel. S to R is parallel to T to U. And then the other 2 sides are not parallel. Which graph shows the image of the trapezoid RSTU after it is translated 5 units up and 3 units left? So translation again. They'll use this fancy math term, but what do we know it really means? What is translation telling us to do?
Slope, right?
Not quite slope. The word I used started with SL though. Slope was a specific formula. Translations were
Slide.
a slide. It's a slide, or you're counting. It just means shift it around. Let me see, show all the answers. So we went 5 units up and 3 left. Which answer choice looks like it's gone 5 up and 3 left?
Yeah. Would be 2 left, right?
one of the answer choices is 2 left instead of 3 left. We want 3 left.
That's only 2. I want to say D.
So D, possibly, that's in the right direction. Ray also thinks D. So let's double check. Whenever I do a translation, I always just look at one of the corners. It's hard for me to focus on the entire shape. So like if we focus on point T only, we want to just count 5 spaces up, 3 spaces left, and see where we end up. So if we go 1, 2, 3, 4, 5 spaces up, and then we do the 3 spaces left. I'm going to do left in a different color.
Oh, let's see.
3 units left. So now our new point T is up here. So C doesn't have T in the right space. We're looking only at point T right now. Which one has point T at the spot where we ended up?
A.
Good. Answer choice A has it in the spot where we ended up. So like I said, I like to focus on the 1 point because a lot of these could have been the answer. A, B, and D all moved up and left. They all went in the right direction, just not the right amount of spaces. The only one you could say at the beginning, you could say, well, C is definitely not it. It went to the right. You're not supposed to go right on this one. So that's why I focus on 1 point only, just so I can get that exact amount of counting, because usually they try and give you answer choices that are kind of close to each other. And so you're like, oh, this could be it. It looks pretty close, but they want that exact amount. Let's see, we still have time, I think, for one more problem. Let me clear what I drew, though. So let's just do this random one. It's not, 19? Okay, we had a request. 19. So.
Yeah, I was about to say, that one looks pretty crazy.
Okay, does look pretty crazy. So a problem like this is best to do with a calculator. Honestly, just looking at it, I have no idea what order it goes in. I don't know what each of those numbers really mean. But we can put decimals in order a little bit easier. So you are able to use a calculator. You don't have to know how to do 31 divided by 4 and get a decimal. We just, and I'm pretty sure this is the calculator, Desmos.com. I'll send out the link again. I sent it out last week, but we had some new students join, so I'll send it out again. You'll see this calculator on the actual, because now it's an online test instead of a paper test. So on the calculator, let me split them up so I can show both at once, and then I'll not have to go back and forth as much. So on the calculator, there is actually a graphing capability. I showed some of that last week. We can do some more graphing next week as well. But I do have a YouTube channel where I've recorded this, so you can see some of the graphing stuff. But these boxes are where you can do your calculator work. So like 31 over 4, we're going to type in 31 divided by 4. Yes, it's a fraction, but the fraction bar is really just division. Oh, I was going to draw it in, but I hit the wrong button. This fraction bar really means do some division. So 31 divided by 4. And you can click with your mouse, or I could have typed it into like using a keyboard, gives us 7.75. So now we have a decimal for this. So now we've got to do it again, this time with a mixed fraction. So with a mixed fraction, the 5/8, that is still a division bar, but we have one extra piece. In our calculator, we have to add the whole number 7 to the 5 divided by 8. When you type it in, you're going to do 7 plus 5 divided by 8. Oh, okay, notice I'm on the same line. It's going to not work because I should have clicked down below and done 7 plus 5/8. Easy to fix though. So now we have 7.625. So the next one, square root, and this is the square root symbol. Most of the time on the calculator, it's just this check mark part of the square root symbol. And that's how it is on this Desmos online calculator. So again, I could either erase what I have and then type it in, or just click below. When I'm working on one problem, I like to keep them all up, because then if I forget something or I made a mistake, I can look back at the calculator. But we'd go down here, it's next to the ABC, and it's this check mark. That brings up square root, and then 50. And it gives you a really crazy answer. We don't really need the whole answer, we're just gonna take part of it. I'm gonna do 7.07. And then the last one's already a decimal. So when you're comparing these and putting them in order, I'm going to write them again just so they can be a little bit bigger and not so smashed.
You forgot the 2, 7.625.
Thank you. Good correction. 7 and 7.82. So when you're comparing these three, often we only need to look at the first spot after the decimal. They all start with 7, so that all matches.
Yeah.
But then after the decimal, they don't match anymore. We have a 7, a 0, a 6, and an 8. That actually tells us the order. Which one is the lowest?
7.07.
7.07. 0 is smaller than 7, 6, and 8. So 7.07 matched up to square root of 50.
So you know that one's going to be the first one.
Yep. So it's either B or C. You know, square root of 50 is first. Which one comes next?
Okay, you got 7.625 would be next. So that is 7 5/8.
Good. And that leaves us with one answer choice.
Let's see.
So yeah, a problem like this is really about knowing how to plug it into your calculator. Knowing specifically that the fraction bar really means to put divide, knowing how to get the square root symbol, and knowing that a mixed number is really plus and a divide sign. That's the hardest one to remember because there's two things going on with the one expression. Okay, we are out of time for today. I think next week we'll be back to the 5 o'clock time, but I'll send you a message on Remind 101 on like Tuesday, reminding you about the session next week. I did record this whole thing, so some of you joined later. If you want to watch the beginning, I'll send out the YouTube link for that. But thanks so much for coming, guys. I'm glad we had so many people here today, and hopefully I'll see you again next week.
All right, thank you.
Bye.
Bye.